now that we know the amount of water, we need to know what would be the size of this thing. What would be the size of, in our case, what would be the size of water, or what would be the size of drain to be provided along the road just now, right? Along that road just now. Along that 150 meter length of curve just now. So, but before that, let us just go through the kind of what we call drainage structure that we usually provide for road projects. So, these are some of the most common type of drainage structure. One is the road surface itself actually a drainage, because water can flow on the road, right? So you can say that structure. So road surface. And second type of drainage is roadside or shoulder drain. You have road here, then on the side you will have a drain. That we call that shoulder drain or roadside drain. And then you have bench or berm drain. It depends. You call it bench when it's on slope, cut slope, berm when it's on the field slope, right? But bench is actually the step of the slope. So that's later on we'll look at some illustration. Number 4 is the toe drain. Toe drain is the drain that is at the toe of the slope. So you have a road embankment. Dekat bawah sana ada drain. So that's toe drain. Right? Toe drain. And then you have a median drain. Median drain, remember? Just now, if the highway is turning right, you have to have a median drain. Otherwise, the drain will cross to the other side. So that's why we provide median drain. Curb drain. Curb drain, sometimes in a usual normal road like that, we have a curb. So water, because of the road is a curve like that, then you have a curb, and then along the curb, water can flow. We call that curb drain. And interceptor drain, I mentioned just now, interceptor, you want to intercept water from higher ground coming down to your side. So that interceptor drain. Outfall drain. Outfall drain is that when you have many distance of berm and bench drain, it will get bigger. Once a lot more water coming down from the slope, there will be a lot more water flowing, and you don't want the drain to become bigger and bigger and then no space for drain. So you need to, if you have a slope like this coming down, this is higher ground, this is slope, there are a lot of drain going that way. So you want to cut off, then you bring down into your roadside drain, which is bigger, and then take it away at certain interval. So that is what we call outfall drain. And of course, number 9 is subsoil drain, and that is a drain below the ground. Okay, what is the typical situation when we have this drain? I don't know whether you can imagine apa benda ni. This is, I think, similar drawing that I showed you earlier. In this drawing, you need to understand when you are on site later on. You need to understand drawing. This is one of them. This is a plan view of a north-south highway road long time ago when I was involved in north-south highway before joining USM pun. This portion here, if you drive a lot to KL, the Bukit Lanjan Jalan Duta ada banyak tebing batu-batu kan. So we design drainage for this site. So you can see this is actually the road, right? The highway, and this portion up here is a slope coming down towards the road. That's why the arrow here is pointing down to the road. So in a construction plan, when you see the slope arrow, okay, is coming down to the road, I mean the slope is coming down. It's going away from the road like this. It is a field slope. There is a field slope. So you can see, in this case, there are drain like a berm drain like this. I think I show you cross section better. Okay. This is remember just now. This is the highway, right? This is 32 bench drain, the bench drain. And then it has got, remember, see this? This is the outfall drain. So when the bench drain flow up to here, it will be taken down. From here, it will be taken down. And then start again over here and goes and start at invert, new invert level and go, and in this case it will join what we call this one here at the end here is the interceptor drain. Interceptor. Right. And over here is a field area. You can see this is a berm. Sama juga, and then you have a toe drain at the end of the slope. Alright, toe drain. So this is a toe drain. That is a cross section. So up here you have interceptor drain. You want to intercept any water coming down. In between, on the slope, you have a bench. So you have a bench drain. And down here you have a roadside drain or shoulder drain. So this is all the drainage that you need to prepare. Of course, in some area you need to provide subsoil drain below the drain. If it is embankment like this, so up here you have a shoulder drain. In between you have a berm drain, and of course at the end you have a toe drain. Right? So toe drain is opposite of interceptor drain. Right? So this is a construction of what drain? Agak-agak lah. Drain apa? That's the interceptor drain. Right? The one down here is a bench drain. And actual picture, mana dia? What drain is this? Nampak ke? Sama dengan tadi lah. You have interceptor up here, you have bench drain here. Right? Bench drain. And over here is the outfall drain. This is the outfall. Right? This is again, this is north-south highway, but I was not involved in this portion. I just took picture of that. Okay, now you can see, I don't know if you can see, again, those are this bench drain here, bench drain, right? And then this one is the interceptor drain. And of course, in the middle of the road here, you see this road is turning left, so water from the other side will coming this way, so there will be in the middle here what we call drain apa? Median drain, right? Median drain. So those are drainage facility in. But then again, even bridges is considered as drainage structure because bridge will allow water to pass below the deck. That means that's part of the road. So for example, this bridge here, I don't know whether it's still there. This is a long time ago. It is somewhere in Balik Pulau. You can see the blue area, and then the kelabu one, the grey one is a bridge deck. So this is water. So we don't use water to flow beyond the bridge level. So we need to know what is the cross section area. That's why cross section area is penting dalam Q untuk VA itu, the amount of water can flow. That is why when some river is silted, then the cross section will be less water will flow, it will overflow. So that's why we need maintenance for road and drainage. Again, sama tadi ada bench drain. This one is roadside drain, right? And this is again, it is roadside drain. Like I mentioned before, you need to have a most economic size. You can, of course, you can provide a drain as big as RT here, but you know that's not economic. But you don't want to provide too small of a drain that later on water will be overflow into this road. This is what I call just now curb drain, right? Curb drain. the water that fall into this road and come in some here will go into this drain and go into this inlet, roadside inlet that goes into underground pipe system. That go some place have grating like that, you know, from the curb. So it flows from the curb, it goes to that grating and goes to the drain below. And for drainage to cross the road, sama ada you have bridges like tadi ataupun culvert like this, right? Atau even smaller culvert yang circular culvert saja. Okay, regular culvert saja. But the thing is, we need to know what is the size. So just now we already know what is the Q. Now we can do the sizing. Alright, now we can do the sizing. So I'll show you some way to do the sizing now. Just to let you know the kind of drainage, this is most of our drainage is open drain like this, but now it's more preferable to have a drain without drain. I mean a drain without drain, you can say that. A swale like this, where the drain is actually a grass covered drain. That is what we call SUDS, or Sustainable Urban Drainage System. SUDS is a drainage system, sustainable system used in the UK. In Malaysia, we call it MASMA, MSMA. Right? But we don't have MASMA for road. We only have MASMA, general MASMA, but you need to adopt that concept lah. But in a country like UK, they have got SUDS for road, not just for general. Yes? Alright, so that's the thing. And this is again a part of our sustainable drainage system. If you want to know more about sustainable drainage system, you can go get more detail from this SUDS. Anytime you search for SUDS, you will get a lot of information on sustainable urban drainage system. Right? I will skip that. In Malaysia, we use MASMA, right? MASMA, sustainability and green approach. And in other countries, we call that slightly different, but the concept is the same. It is about sustainable drain system. In the US, it's called LID, Low Impact Development. In Australia, it's called WSUD. In UK, tadi SUDS. In New Zealand, RIUDD. In China, it's called Green Manual. So there are many terms used for sustainable urban drainage system. Kita pakai MASMA. Right? So, okay, this is again back to the road crossing using, in this case, a culvert or you can say bridge, right? I don't know. It looks like a culvert to me, big culvert. Of course, how do we decide what size of culvert kita nak pakai? Kita ada banyak size, kan? That depends on the risk that you are going to take. Tadi itu. What risk you are going to take, right? You can have, for example, you can see here the dominant size is 3 meter by 2 meter, or 3 meter by 1.3 meter, or 3.3 meter by, this is a big size culvert, like that. Or even smaller one. So, which one you want to use? Or, if you don't have this one, which one is compatible to that size, right? So the important thing to find the compatibility is the cross-section area. Because the cross-section area will tell you the amount of water will flow. Sometimes you have shape like this. Again, it's circular, different size, different. So like I said, the major consideration for water flow is the cross-section. Let's say, in this case, this is preliminary, okay? Not just to get some concept. If you need to convert from rectangular drain to circular drain, for example, your father has got a machine that can produce circular drain instead of rectangular drain. But the project that you have got specify to use the rectangular drain. Definitely you want to use a cheaper drain. So how are you going to counter propose. This is a practical what they call issues on site lah. On site. So what you want to do is to find what is the cross section area. That gives you compatible water flow. Of course, you need to consider more things like slope and things like that. But the area is the first. So you will use this. You will utilize this formula just now. The hydraulic formula I mentioned. Q equal to VA. V is the velocity. A is the cross section area. In this case, we are looking at the area. So area for this rectangular 2 kali 2.5. So the area is 5 meters square. Right? 1 unit of box culvert. You want to convert your box to circular culvert, pipe culvert, right? So what you need to do is to find the equivalent cross section of the culvert. That means at least 5 meters square. So you want to do some analysis. What circular culvert size will you use? Of course, you need to do some trial and error, right, to find the answer. So at first, you let the diameter of the culvert will be 2, right? Because the height of this culvert is 2, so you try 2 also for this pipe culvert. Now you find that area, if you use diameter of 2, is only 3.14. Satu pipe, area dia 3.14 meter square. Tak cukup, 5. But no problem, you pakai 2. So you dapat 6, which is more than 5. So, okay. Now you can counter propose. Kata, now I'm going to, can we propose this? And this is a justification. Something like that. Okay? Oh, ini is actual exam question. Long time ago. It won't come out anymore. But, for your information. Ada markah tu. 14 markah, 6 markah. Okay, just now I mentioned about subsoil drain. Subsoil drain. So this is a typical subsoil drain that is below the ground. The subsoil drain can be concrete or poly pipe like this. Usually they are installed like this below the ground. And for road, they will be placed at the end of the road, because we don't want water to come below here. You want to catch all water. You don't want water to come nearer to the surface, because that will weaken the subgrade. Okay, we want to protect the subgrade. So whenever there's a what they call water coming, it will cut here. It will not go up here. Right? So that is subsoil drain. And on the slope, you can see the green line is the slope, right? Green. The dashed line is the original ground. Originally, when you have not cut the hill for your road, the ground level is here at the blue dot dash line. Now, you cut the hill, you disturb the original water profile. There will be, if you do this, the water will still coming out here and then come to your road, and also or maybe disturb the stability of the slope. So what in this case what is done is the insertion of a pipe into the ground to remove water before they reach the slope surface. So this will adjust the water profile to become like this. So the water profile now will flow like the solid blue here and go below the road instead of disturbing the slope and also coming out on the road. So that is a purpose of a subsoil drainage system for road. In this case, slope. Okay, that is all my slide. But ada satu lagi exercise kita nak buat. Okay, exercise kita buat. Remember tadi kita dapat Q 0.04 meter cube. Now, you dapat 0.04 meter cube. What will be the drain size? What will be the drain size? What will be the drain size? Okay, I did some calculation. But first, before that, the drain size the Q equal to VA, sama macam culvert tadi kak, must be bigger than 0.04. Whatever QVA you want to get, right? That's the concept. V, remember, 1 over n, r to third, s 1 half. Right? Okay, but today, we go back to the 150 road tadi. Right? So, remember tadi jalan kita kan, kemudian ada curve 150 km and straight balik. Oh, 150 meter length of road. Right? So, because 150 tadi, kita dapat Q tadi pas 0.04 meter cube per second. Right? So, let's say, based on that 0.04 meter cube per second, you choose a drain size, median drain. Right? Remember, bila ada curve, dia ada kat tengah, kena ada drain kan? So, you choose to pakai, in this case, I use 300 by 400 drain. Is that 400? Yes. 400. This is mm, right? Wah, nampak tak? 400. Can you see it? Oh, boleh. Okay, 300 by 400 drain, right? So over here, so this drain will be from here to here lah. And it will discharge somewhere. Kalau dia dah straight dah, straight tak perlu drain. Remember? Dia jelas straight, dia tak perlu median drain. Sampai ujung ni dia kena discharge lah somewhere. So it go to culvert. Dia keluar api mana-mana lah. Okay? So this one here. Alright. So which is now that you have chosen 300 by 400 from your Q go to VA analysis tadi tu, you find the A, so that means your 400 multiplied by 300 ni, multiplied by velocity, you will get more than 0.04. That's the assumption, right? So now you are using 300 by 400. So that is about, this is 300, so 400, right? Drain tu besar ni lah. 300, base 400. Dia orang besar ni lah, jangan drain, tak besar mana pun. Okay? So that's the drain that you decided to use. Now, kita nak buat some calculation. At the start, at the beginning here, definitely lah, this is, kalau ni jalan, mesti dah turun sikit kan drain tu, dalam ni. Kan, turun. So, you turun, katakan tadi, turun 400. Right? Daripada surface. Jalan tu. Kau air masuk situ kan? Air masuk. So, ada drain. So, now the depth is 400. Based on the size. Now, you want to know, when you know the depth, you know what is the invert level dekat sini. Invert level is paras dasar. You correct paras dia. Invert level dalam meter from mean sea level. So when you do construction, kita punya level pakai theodolite apa semua tu, level kita dalam mean sea level. Okay, let's imagine the mean sea level here is earlier I did, what was that? Tak apa lah, anyway, 50. Let's say the present invert level is 50.0 meter from mean sea level. Invert level kat sini. So bila you teropong, that's the level. Okay, now you imagine the length is 150, right? So this drain will travel 150 before it discharge. So you want to find what is the invert level dekat ujung ni. Remember, it cannot be flat kan? Kita punya drain cannot be flat. It has to go somewhere. It has to go lower. So how do you lower the drain? Let us look at the design standard. In this case, it says the slope of the drain should be 1 in 200. Paling shallow. Sebab kalau lagi landai, air tak boleh jalan. Dia kena 1 in 200. Ataupun lagi tinggi. So in this case kita kata 1 in 200. 1 in 200 means every 200 meter the drain will drop 1 meter, right? Every 200 meter drain drop 1 meter. So that's the meaning of 1 in 200. When you say slope 1 in 200, that is what it means. Sama lah juga, remember last time kita cakap tentang slope tebing kan, 1 to 1. Maknanya every one distance it drop 1 meter. That is 1 to 1. Now the drain punya slope is 1 to 200. Maknanya 200 meter baru dia drop satu. Okay, so soalan dia ialah what will be the invert level here? The present invert level is 50. 150, di sini 50 invert level. What is the invert level dekat ujung ni? Jarak dia 100 meter. Slope dia 1 in 200. That is the question. Can you find what is the invert level? 1 in 200 also means every 1 meter the drain will drop 1 divided by 200. Faham tak? Understand? Every 1 meter from here to here the drain will drop by 1 bahagi 200. Setiap 1 meter dia akan drop 1 bahagi 200 meter. Jadi kalau 200 meter kali 1 over 200, dia drop 1 meter lah. That's why 1 in 200 kan. So every 200 meter dia drop 1 meter. Kalau every 1 meter dia drop by 1 bahagi 200 lah. So 1 divided by 200 is what? 0.005 meter. Then you know the distance now is 150 meter. So you multiply je lah 150 by 1 divided by 200. Then you know what is the drop amount. So what would be the amount? So what is the amount of drop? Ya kan? Have you got the answer? Anyone? The amount of drop first. Daripada point A, let's say this is point A. This is A, this is B. What at point A, how much drop point B from point A? Of the drain invert so that water can flow. But kira lu. So, macam mana? Remember tadi, the slope is 1 in 200. So, maknanya kalau 200, it drop 1 meter. So, kalau soalan ni katakan, jarak dia 200 meter, you know already now. But the problem here is that the length is only 150. So, kalau 200, memang dia drop 1 meter. So, 150 berapa? That is a proportionate lah. Proportionate-nya calculation. Proportion. When you know how much it drop, then you can deduct from the 50 to get the invert level in mean sea level. 49 model. Okay, that is invert level lah. Okay, betul? Yeah. Anyone got anything other than 0.75? 0.75 is the amount of drop. Yeah? The drop. Yes. The 50. Yes. Then you get the level over there. Because the present level at A is 50. So how much? It dropped to 0.75. So it become, dia tinggal lagi 49. Sikit lagi lah. This is this is step number 2 ialah untuk check untuk check what is the Q. Okay, check, to find what is the Q of this drain. Remember the slope is 1 to 200 kan? Okay. Now, what is the Q inside the drain? The Q is the water flow. We want to check water flow whether it is sufficient to, for example, to cover this 0.04. What is the Q? Q, remember, equal to VA kan? A is the cross-section area of the drain, which is 300 by 400. Or kalau meter 0.3 by 0.4. That's A. Confirm, dah tahu lah. Ini dapat 5 markah. Senang kan? So now what you need to know is the V. Remember, the V is equals to 1 over N R 2/3 S slope 1/2. So now what is R? Tadi kita sebut tadi kan, I show you earlier. R is to A divided by P. The cross-section area, which is the one that you got just now, divide the weighted perimeter, which is this one here. There is the R. Now it's just a matter of plugging in the figure into the formula. And what is S? S is 1 in 200. Right? So you just use 1 divided by 200. Masuk sini lah. Right? Because S is in meter per meter. Every meter, how much it drop? I remember just now, I kata, every meter, kalau slope dia 1 to 200, you divide 1 bagi 200, you dapat lah meter per meter punya drop. Now, based on that, you can calculate the V. Now, once you have got the V, you multiply by A, you get the Q. Okay, now tell me what is the Q. Guna formula tadi.